Alright, let's look at this problem called last day where you can still cross. Let's have a read. So we are given a matrix, a 2D matrix, and the cells values are 0 and 1. 0 represents land and 1 represents water, and we are given the rows and columns of the matrix. Initially on day 0, entire matrix is land. That means the entire matrix, all the cells value is 0, which is land. However, each day a new cell becomes flooded with water. So on every consecutive day, one of the cell changes from land, which is 0, to water, which is 1. And on a specific day, which cell changes from land to water is specified in this array, and it is 1 based. You want to find the last day that it is possible to walk from top to the bottom by only walking on land cells. Okay, you can start from any cell in the top row and end at any cell in the bottom row. You can only travel in the 4 cardinal directions. Return the last day where it is possible to walk from top to the bottom by only walking on land cells. So this is day 0, this is day 1. This guy changes to water, then this guy changes to water, then this guy changes to water. We could traverse from top to bottom, traverse from top to bottom, traverse top to bottom, couldn't. Similarly here at this point we couldn't, so this is the last day. Similarly here we could traverse like that, here we couldn't because you can only go in 4 directions. So after this you could go either here or here, both of them are water, so you couldn't go. So what do we need? So one thing we notice is only interested in land cells. Start from any land cell on top row, reach to any land cell on bottom row, traverse only in 4 directions, and land to land only. Right, that's the bit. And the bit is on every day. As we can see, the state is different, so we should be able to first create state on a specific day. So let's solve for, so let's do this. We return a matrix get grid on day, and here we will do what? Just return D, and we'll have this cells array. So first let's do this. So you go so we initialize. Okay, you want row and columns as well. So we are initializing how the grid looks on a specific day. It's all initialized to 0. Now on each day till this day D, so I equals to 0, I is less than equals to D, I plus plus, one specific cell changes from land to water, which is that specific cell on this ith day. So R equals to cells 0 I, and it's 1 base, so you'll convert it into 0 based, and similarly C equals to cells, I think I messed it up, it's I0, and this is 1, again 1 base, convert to 0 based. So this specific cell, this RC, it changes from land to water, so it changes from 0 to 1, and you return grid, right? So this is the grid on a specific day. Now another helper function we can write is, what we can really want to solve is a can pass, right? Can you pass from top to bottom, again on a specific day, and you can go row call cells. So first thing you want to do is you want to get the grid on the specific day. So get grid on day, you go D cells row call, so you get the grid on the day. Now we can either do BFS or we can do DFS. Let's try BFS first. So we start with the Q in BFS, right? So you go Q, we got an integer array because it's 2 points we want to say. the location of the cell. New linked list. Now add land sources to the queue, right? So what are the sources here? The sources are the starting points that are allowed, and they are all the land sources, so which is essentially on the top row. So look at all the cells on the top row, which is if grid top row column is I. If this is 0, then you want to add it to the queue. So I add it to the queue. How do I add it to the queue? 0i, and I want to, once I have already visited, I don't want to visit it again. So for that I change the value to something else, or I can keep a separate visited array, or I can just change this value to something else. So if grid ij is -1, that means it's a land cell which has already been visited, right? That way we can handle it. The visit concept. Now this is what we are trying to solve now. So while our queue is not empty, we get what was the cell. This cell was, and now you want to go in different directions. You want to go in 4 different directions here, right? So let's define those directions maybe here. So you have these directions. You can go in 0 -1, you can go 0 1, you can go 1 0, you can go -1 0, right? Whatever the directions you want to go to. So let's go to all the 4 directions. So for each direction, let's see where we land. So R would be what? Row would be so this was the row to begin with, and it gets incremented by this. Similarly, the column would be now. What do you want to do? You want to add these cells into the queue, but they have to be within the grid first, right? So they have to be within the grid. So R is greater than equals to 0, C is greater than equals to 0, R is less than row, C is less than column. What else? And I'm only interested in land, right? So especially non-visited land, because visited I don't want to repeat stuff. So only interested in non-visited land, which is 0, because if it's visited, it has been converted to -1. So not interested. Now what I'm looking to see is, can I reach a land cell on the bottom row? So if this is a land cell and it is the bottom row, then I'm done. And if that's not the case, then okay, we'll proceed further, and proceeding further means we'll add it to the queue. So again, you don't want to visit the same nodes again, so you mark it visited by changing its value from 0 to -1. And at the end of this while loop, if you're still not ended up on any, if you're not returned true, that means you return false. That means there is no path from a top land row, top land cell to a bottom land cell. So that's the bit. And now last day to cross. So let's see if we can do. So let's find the first day where we couldn't cross, and the last would be the day previous to that, right? So for int t equals to 0, t is less than cells dot length t plus plus. So if we cannot cross, if we can't pass, not can pass, d row call cells. So if I can't pass, that means the previous day is the answer. and if I can pass for all the rows, that means for the last is cells dot length minus, so this is the last step, so that was the last step. But see, if the first day itself you can't pass, and you return -1. Now the first day when you can't pass, when d equals to 0, it's actually first day, it's not the 0th day. So basically, because it's for example, if you look at this bit, uh, this is the 0th day, this is the first day, and the cells of 0 is actually indicating the first day, which is where it's one base, and you have to convert, sorry, you have to convert to one base, so you have to do +1 and +1, or you can essentially just, you know, replace these, change this. Let's run. Okay, fix compilation errors. Alright, run again. Fix some more. Line number 58. How come I forgot to declare correctly? Alright, line number 24. Number of columns is this. Alright, the test case passes. Let's submit. Seems to be taking time, and time limit exceeded. Alright, 98 test cases passed, but there are around 10-20 test cases that did not pass. So that means our time complexity needs to be improved. So let's see what's the time complexity right now. So we are going through this loop. Cells length, how much length is of the cell? So cell length is row times column. Okay, so row times column, and for every row times column potentially we'll do a can pass will do a BFS, which will again be going through each and every cell. So again, row times column, so it's row square times column square time complexity. Can we optimize this, or can we optimize this? Do we need to check each and every day? If I can pass on day number n, then I can also pass on days 1 to n minus 1, right? So which is where you can try to, so basically if can pass is an array, right, of, so if I have can pass array, it would be either yes, and then no, right? So it's a sorted array. You can do, it's sort of sorted, right, with only two values. So you do a binary search here instead of a linear search, and reduce this to log n. So let's try that. So what do we do? So let's say left equals to 0, right equals to cells dot length -1. Now while left is less than equals to right, mid is left plus right minus left by 2. Okay, now if I can pass on this day, what does that mean? If I can pass on this day, then I can pass on all the previous days. So either this is the last day, or the last day I can pass is on the right side. So let's look at the right side. The right side means I change left equals to mid plus 1. What is the else case? Else, if I cannot pass on this day, that means the last that I pass has to be on the left side. So on the left side, that means I change right to mid -1, and we keep doing that. At the end, I'll left with a single cell, and I'll either get a can pass or cannot pass. So let's consider this case. What if the first cell itself, where left equals to 0, you cannot pass there itself? If you cannot pass there itself, that means your right will become negative, or less than left, and left is the day that you cannot pass. So potentially the answer will be left minus 1, right? So left is what you cannot pass, and so left minus 1 has to be the answer. Now if you are able to pass even on the last day, right? So to begin with, like let's say you have 10 days, and on index 10 also you are able to pass. That means the last is in which case, when you also, this will be the case in which case you will, if your left was 10, right was 10, you will change left to 11, and then you wanna change it back to 10. So you would do, essentially you wanna do left minus 1 in both cases. But again, because it is 1 based, you will want to do plus 1, and so you can just return left. So let's run again, let's see if this works, and submit, and finally it works. Let's go back. So we talked earlier that hey, we can do DFS, we can do BFS. We did BFS here. Let's see if we can do DFS as well. So in our can't pass, let's comment out the BFS code. So this is our BFS code. Now let's see if we can do DFS. So for DFS we get the grid. Now we want to see if we can pass the grid, right? If we can pass, so we want to do DFS from all the land cells on the top row. So for oops, I equals to 0, I is less than call I plus plus. If this is a land cell, so sorry about that. So if row is 0 and the column is I, and if this is a land cell, then I do a DFS on it. So DFS I pass, what do I pass? I pass 0 I grid row and column, all of these I pass. If DFS returns true, then you return true. DFS will tell if you can reach to the bottom row, and else you just return false. So let's solve this DFS. So DFS is returning boolean. You go DFS, you are saying you get RC. What else are you getting? You're getting this grid, you're also getting this row and call. Okay, so let's see what to do with DFS. Firstly, you want to ensure that you're not out of bounds. So if R is less than 0 or C is less than 0 or R is greater than equals to row or column is greater than equals to row, sorry, call. If that's the case, then you just want to return false. What else? If you are not a land which is unvisited, if you can do it here itself. If it's not equals to 0, then also. So all other cases. Now you want to mark it visited. It's a land, you want to first mark it visited. So, and the way that we are marking it visited is we're just setting its value to -1. That's where we say it's visited. And now what do we do? Go in each direction. No, before that, if you finally reached to a cell on the last row, then you just return true. And if that's not the last row, then you look at all directions in. Okay, so for each direction, new row is what? R plus direction 0, and say C plus if this DFS of if you are not the last row, fine, but if you can reach to the last row, and you only want to consider land, but you are checking it here itself, so that's fine. And if that's not the case, then you want to return false. Okay, let's see if the DFS logic works as well. And okay, submit. Cool. So we solved this problem using DFS and BFS and the binary search to improve the time complexity. With binary search, so without binary search, our time complexity was R times C times R times C, and with binary search, our time complexity is R times C times log of R times C, right? That's the thing. All right, that's it.